systems of linear equalities. And when you solve systems of linear equalities, we showed you a couple different ways. Specifically when it came to graphing, we'd say draw the first line, f of x equals mx plus b. Graph the second line, g of x equals mx plus b. And tell me where they intersect. And you'd look at the graph and you'd say, yeah, right about there. We're going to change this from equalities to inequalities. And inequalities are things like greater than or equal to, less than or equal to. You can't solve these with substitution. You can't solve these with elimination. You can't solve these with matrices. You can only solve them by graphing. Your answer is going to be a picture. Let's go back to long ago, chapter 1 and chapter 2. If I gave you something like x is greater than or equal to 5, you would draw a number line, you'd put a tick at 0 and a tick at 5. You'd say, I got to plot a dot, and we'd say open dot or closed dot. And you would look at the inequality symbol and you'd say that's a closed dot. And then this says x is greater than. So that would mean you would shade above the 5 to the right. Now what we're going to do is we're going to take this idea, and instead of doing it on a one-dimensional line, we're going to do it on a two-dimensional plane. And there's two things we need to talk about. First of all is the sign. If you have something greater than or less than, in the one-dimensional world, that was an open dot. In the two-dimensional world, this is a dotted line. On the other hand, if you have greater than or equal to, less than or equal to, that was a closed dot. This is represented by a solid line. The second thing you need to determine is whether you shade above the line or whether you shade below the line. So if it says greater than, you shade above the line. And if it says less than, you shade below the line. So let's say f of x, we put less than or equal to, and you would shade below that solid line. All of these points, all these ordered pairs, make f of x true. Then you would do the same thing with g of x. If we had g of x is greater than, then the first thing we have to do is we have to change our line to a dotted line. That represents an open dot. So now we have a dotted line. And greater than means we need to shade above that line. So we're going to shade above g of x. And this breaks our graph up into 4 regions. 1, 2, 3, 4. Region number 1 is not shaded by either one. And those are points that don't make either equation true. Region number 2 is the green region. Those are points that only make g of x true. Region number 4 is the red region. And those are points that only make f of x true. And region number 3 is the dark region, the overlap. Those are the solutions to the system. Those are the ordered pairs that make both inequalities true. Region 3 is your answer. So you graph the first line, ba-dump, ba-dump, and then you decide what side do you want to shade. So you got to drop 3 points. 2 points for the line, and then the third point you drop for the shading. So maybe we shade above. And then you do the second line. 1, 2, and here is the purple region is the solution. This is a solid line. If you need a dashed line, you select this icon. They give you the shaded region. They just want to know the vertices. What are these corners that bound the region? So you just put in ordered pairs, like 0, 0, and then whatever this coordinate is, 0, 8, 6, 7, 10, 0. You put in those 4 points and you got it. The next one, they don't actually give you the shaded region. They just give you the lines. You got to look at the equations and say, oh, this is going to be y is greater than. So that means on the green line you shade above. On the blue line you shade above as well. So what are the vertices? What are the intersects? It's going to be this point, and this point over here. So your graph may be different. And your graph may say not greater than, but less than. Here's one line, shade below. Here's another line, shade above. And there's your solution.